Hello everyone, welcome to pipebench.com. Today I would like to introduce a very new tool we have uploaded to our website. It's called a HDD installation and analysis tool. This tool is designed to help you to run stress analysis and design a geometry of your HDD project for steel pipe. This is a new tool. We put it on. The first step, if you go to our main page, you probably see this tool is currently locked. And if you click on it, so you could have an overview of what this tool is about. But right now it's locked. You will have to log in and subscribe to unlock the tool. But we can run down this really quick. Basically, the first section is to help you to design the HDD profile. It's about the geometry. This is all the parameters you will need to design the geometry. Later on, we're gonna go through the whole process. And then later is some basic design parameter for your pipeline. And going down is gonna be in the sections for results, including the operational stress analysis to meet your governing design code compliance, and also there's pullback loads analysis. And at last, it will have the installation load stress. They will tell you all the allowables and the pass or fail criteria. Okay, let's take a look at it, how to use this tool. Before we start, I would like to highlight that we actually provide two different units for people around the world. For the folks in the United States, like me, we typically use Imperial, and for the folks outside, the metric's more common. So you can easily switch back and forth between Imperial and metric through these buttons here. That way, it will convert everything essentially in the calculations, in the results, to the unit system you want to use. So if for this demonstration video, I'm going to stick with the Imperial. So the first section of this tool is to help us to build up the HDD geometry profile. As you can see, there is a profile figure here, and also there's a section below for us to put in the HDD geometry inputs. But before we do that, I would like to highlight that we do have the ability to put in the ground surface the surface data through this button here. It's going to pop up a new window. Essentially, you can just put in the stationing, whatever you use for this crossing, and put in the ground elevation. So you can put how many lines you need through here. Basically, every line will have a set of data. The first is going to be stationing, and you should have a space to separate the numbers, the values. And then you will have the second number as elevations. So for some generic design, you don't really have the ground data. Let's say you want to use just a flat line to show the ground level. So you could just change everything to stationing 0 to at 1,000 feet, and at a stationing 1,000 feet, you get 1,000 elevation as well. So and then you click load data. Sometimes it's gonna take a little bit for this to react, and then you will have basically a flat ground profile. And for those guys, actually, for your project, you do have the survey data points. There is an easy way to do this. Essentially, you click here again, and here actually have some generic survey data provided here. So you can see the stationing and elevation. So let's say you get this data from surveyor in an Excel sheet. Essentially, you just copy this, and then let's say clear data, and you put it in here, copy paste, and then you load data. So this is how you load the ground data. But for today's demonstration, I'm gonna just use a generic flat ground. So I'm gonna clear data here and put in some generic ground data, just like what we had before. Load data, and it's gonna to show you how to change the HDD geometry inputs. So in this case, let's say an entry point elevation has to match the ground. We keep the station at 0 to show the overall length. And then entry angle, you can put in here typically between 10 to 12, but basically any angle between 8 and 20 is okay. So in this case, we can go probably a little bit, off the typical range. Let's say we want to go with 14. And entry radius of a curvature, let's say this is going to be a 10-inch pipe, so it's going to be 1,000. That's the nominal radius of a curvature. Depth of pipe at the horizontal section this is actually the depth from the entry point. In this case, we can have 50 feet. Exit angle, let's keep it 10, for example. And then radius curvature on the other side, let's use 1,000 as well. And exit point elevation is here, stationing, let's keep it 1,000 to match. So as you can see, this geometry is going to change instantly with the input you put in the cell, and you can basically see your geometry. And then if you really have ground data, you could check if the HDD drill path has enough clearance to the soil, to the, like say, riverbed, to the third-party utilities. And then in this section, you could be able to tell what's the summary of the geometry, the length at different section, basically different section, straight section, curvature, horizontal straight, curvature. So it's all gonna be showing here. Okay, so once the geometry is set, and then the next part is to put in the pipe design parameters. So in this case, we say it's gonna be 10-inch. There's a drop-down menu. You could just select the 10. This is where you put the wall thickness. In this case, can be standard. If you have non-standard wall thickness, the way to put it in is to go through this drop-down menu for size, go to custom, and then once you click that, it's going to pop up a window for you to put in the outer diameter. In this case, for example, 10-inch, 10.75 inch. You can input the basically pipe outer diameter and pipe wall thickness manually. In this case, let's say you want to use, like say 0.25. So you could manually put this number in, and the same thing for the grade. There's a drop-down menu for you to select the grade you want to use or you want to try. And again, if there is a non-standard grade, you could use the custom to manually put in the specified minimum yield strength. So in this case, I'm going to keep a 42. And then for Young's module of steel pipe, this is all typical parameter. We have already put it in the input, but if you want to change any of this, you could just click, tick basically the box before, and it's going to trigger this cell to be activated. Then you can now put in everything manually. For example, here sometimes we use 30,000 KSI for the Young's module of steel pipe. So in this case, you can just put it, you can input it that way. And then coming to this side, coefficient of soil friction. Again, this is a generic number, but if you have a known number from a geotech data or geotechnical engineer, you could click the box here to manually change it. Same thing happened to the fluid drag coefficient. Again, this is the recommended value, typical value from the industry. So, and then coming down here, if you are trying to use the ballast during the pullback, you could put in the density of the ballast. Same things, similar thing to the drilling fluid. I'm gonna keep everything like this. This is all the typical value. And coming down here is MALP. In this case, I'm gonna choose probably 740 psi. I assume it's gonna be class 300 pressure rating. For installation temperature 75 and operating temperature, let's go to 120 Fahrenheit. So once all the inputs is in there, the geometry inputs is in there, then you can check the calculation result through the result section. What's showing here is the operational stress. As you can see, everything's passed. And if you're using a different, so this default value I think is based on ASME 31.4, but if you're working in another country that you have a different governing code, you could manually change the allowable here. Let's say, you could change it here to based on your code. But this is the different stresses criteria. In this case, I'm gonna keep it 72% SMICE. So everything looks good here, and then you can then take a look at the pullback loads. This is to give you the breakdown how we gonna calculate step by step for every segment what's going to be total friction, what's going to be the total pull loads required, and then you can see the overall value here. So the entry point is going to actually, you can see the biggest pullback force, and you can see the total value here for the maximum pulling load. So this can help you to select the right rig size. And then the next section is to show you how the pipe's going to behave during the pullback and under the pullback loads. So this is a different criteria, still stress-based to check it. Make sure the pipe, tensile and bending stress and combined, everything is compliant with the code. So far, this is showing everything's passed. So it means the selected geometry and the pipe inputs is acceptable. But if any of these criteria show to fail, then you have to do a troubleshooting to see what's going to be the issue. Maybe change the radius, change the drill path, make sure that, we use a bigger bending radius, or you can use a thicker wall pipe, or you can use a higher grade. So there's a multiple ways for you to make it pass, but we're not going to elaborate more in this demonstration video. So once we finish the design, there are multiple ways to save the results. As you can see at the bottom, there's a save, open, download, and a PDF report. So save means you can save this calculation on a cloud server. So it's gonna be there secured under your account. So every time you log in this PipeEng account again, you can find this calculation. You can reopen it too. Open means if you save this locally, it can open a local JSON file. And download, it means you can download to the local computer as a separate file. You can send this file to others if they have the same tool. But next time you can open this from local. And PDF report is to generate a PDF version of the whole calculation, the geometry, everything for you to file for your projects. So for this demonstration, I'm going to go with the local save and load features. So in this case, for example, we're going to download. Let's say we save this as a HDD demo local. Right, and then we just save, and it's gonna save a file to your local drive. Okay, so let's say you refresh the page, just now all the previous inputs are gonna be gone, everything's gonna be back to what we had default. So now you can come here, say open, and then you can find this file just saved, and click open. and your previous input should be already uploaded here. As you can see, this is the inputs we put it in throughout the design. Another way is to save in the cloud. You can use the first one. You can click save, and then you can, let's say it's the same thing, demo cloud. Then click save. So this page will be re-rendered. As you can see, it's already showing you saved this by who. This is my profile name. Basically give you the time and dates where you saved this, and as you can see, the data you saved already here. Next time when you want to revisit this calculation, you could go to let's say you go to the files, and this is where you can change your profile, everything, your subscription, and get your receipt for order. But here in the files tab, as you can see, this file is already successfully saved in the cloud, and every time you can just reopen this and to give you the calculation you already did. And the last way is going to be the PDF report. The PDF report, if you click on this, you can put in the project's name. We can say, HDD demo, and put in date. You can put in today's date, and then put in revision, put in who is the reviewer, developer, who's the reviewer, and then you can save this. You can download this, right? So in this case, we're gonna download it, and we can reopen it. As you can see there, the report is already generated, and your inputs are here, and also give you the figures for your geometry. Just one more thing, for those files saved in the cloud, which is this file, as you can see, this is already shown. This is actually saved in the cloud. There is one more button at the bottom. It's called update. So this is for you to update the files you saved in the cloud. And save as is to save as a separate file, which you have to use a different file name, of course. So for the updates, for example, you come in here, there's some changes for the design, and you want to, for example, you want to change it to 8-inch, right? So let's say you go to 8-inch pipe, standard wall thickness, you want to change it to, X52, for example. You want to use the default module of steel pipe, and let's say now you want to update this, right? So it will give you another window saying, are you sure to update this file? You say yes, and again, this file in the server is going to be updated. As you can see, the changes has been updated to the file saved in the cloud. I think this is what we put it in. So this is a convenient way for you to revisit and re-update your file, and of course you can choose to save as a different files and to keep the previous one. You can say it's try 1, try 2. There's a lot of ways for you to save the calculations. Okay, that's pretty much everything about this tool, how to use it, how to save it, how to present it, and how to load the data and maybe share with your coworkers. So if you have any questions, feel free to let us know. You can contact us through help at pipeeng.com if you have any questions or maybe recommendations how to improve it. We are always, welcome any comments and feedbacks from our users. That's everything for today's demo video. I wish everyone a great day. Thank you.